George Limpert is our next speaker. George is an atmospheric scientist here in outer space or the School of Natural Resources, one of the two, but a research professor here in the school that will talk to us a little bit about research capabilities with radar. So with that, Dr. Limpert. And if you want to share a screen.
Yes, I will be sharing my screen.
Okay.
Let's see if I can. I'm used to Zoom with this. The interface for Teams is just a little bit different, so I got to figure out what I need to click on. But I think we're just about good to go. So hopefully you can see my screen here.
Yes.
That sounds good. Okay, so this is a little bit of an unusual presentation for me because I'm normally used to presenting about things that I've done or where I have a specific project in mind. And this is a little bit different because I want to talk about some of the capabilities that we have with weather radar for things like tracking birds, insects, air pollution. But there isn't a specific project that this is tied to. And we would need to develop an algorithm, or not really develop an algorithm, but integrate algorithms into some existing frameworks that we have in order to do this. So there's a little bit of work that needs to be done. It's a little bit unusual because, like I said, I'm used to presenting things that are much farther along, but here goes. So I want to talk a little bit um, about what we can do. Um, and just give you an idea of what I'm going to discuss. So I'm going to give you a little bit of introduction to how weather radar works, and then I'm going to talk about some of the potential applications, show you some examples. If this was at a weather conference, I would probably go into a lot of detail about the algorithms. I'm not going to do that today. I'm just going to kind of give you an idea of what this looks like, show some examples, and discuss what we can do. Um, In particular, I'm going to focus on tracking of smoke from fires. Every spring in the Flint Hills, there are prescribed burns, and if you're north of there in a place like Lincoln, you get the smoke from those. And I remember an observation last March, I think it was, or April, where the visibility in Manhattan, Kansas, was down under a mile just because of all of the smoke. And you've probably seen the pictures this summer from New York City, where the buildings were just shrouded in smoke, and it looked like a scene that would have with the sky that would have been appropriate for Mars. So we're going to talk a little bit about what can be done in terms of using radar to track smoke from fires. One of the good things about this versus using satellite data is it's easier to track the smoke at night as well. I'm going to talk about real-time tracking of migratory birds, and I'm going to talk about um, what we can do perhaps for building long-term detailed maps of migratory bird flight. But there are a lot of different applications, and perhaps you have some other ideas about how this can be used. So we already have software for downloading and processing lots and lots of weather radar data. It's actually stored in the cloud with Amazon on their S3 cloud, and we just download the data from them, process it on high performance computing systems at UNL. I believe they're actually located in Omaha. We just download the data in bulk, process it, and run our algorithms on those systems. And we actually have a lot of those algorithms already created. What we need to do, though, is to take this framework that we have for acquiring the radar data and processing it and incorporate specific algorithms to detect and track things like birds, insects, and smoke. Right now, what I've done is primarily focused on tracking signatures that are related to severe storms. So it's a little bit different processing, but we could fit these types of algorithms into this framework. So just a little bit of background on how weather radar works. So the images that you're used to seeing probably look like something over on the right side of the screen. That's a supercell moving through central Oklahoma. Probably a very, very tornadic and very dangerous supercell, if I remember what this event is. And the way this works, the way you get these images is that the radar sends out these pulses. And you can see an example of this. And the pulses hit whatever's in the way of the radar beam, whether it's birds, insects, cloud droplets, raindrops, hail, something like that. And any of those things, they bounce off those, and the pulses get scattered in all directions. Some of that gets bounced back to the radar. Now, if you have larger objects that the radar beam is hitting, or you have more objects in the same volume, you're going to get larger values, uh, more of the energy returned back to the radar. And that's what this image is showing on the right-hand side. So you get an idea of the precipitation intensity, perhaps some hail in the core of the storm, but you get an idea of that from looking at this radar image. This is fairly typical, and a lot of times we use it for tracking severe storms. And again, this is for many years, this is what the radars did. They just sent out a horizontal pulse, and it would bounce off the whatever it strikes, whether it's birds, insects, clouds, something like that, and it would tell us something about the number of objects and the size of the objects within the radar beam. Now, about a little more than a decade ago, there was a major upgrade to the radars in this country, and we implemented something called dual polarization. And the dual polarization sends not only these horizontally polarized pulses, but also vertically polarized pulses, and they bounce off objects as well. This gives us a little bit of more information about what the radar beam is detecting. And so we can use this to distinguish rain from hail. We can use this to distinguish um, weather related echoes like rain from things that are biological or otherwise non-meteorological, like smoke. We can distinguish insects and birds. We can use the information about the shape to make that determination using this data that became available starting around 2011, 2012. So we have a little more than a decade of data collected this way, where we can get more detailed information about what the radar is tracking. And so I want to focus not on what was 2 slides ago with severe weather, but focus on other things that normally as meteorologists we're not as focused on, but are really the main point of this talk. So this is perhaps a typical radar image on a clear summer night. It's from June 26th, June 26th, or probably the night of June 25th, 2023, looking at the times on there. And you have a loop here of just a bunch of blue stuff. And what you're looking at here is insects. There's no precipitation here. It's a clear night. And you can kind of get an idea that the insects, if you look at this, are moving from, if you just look at the blue area here, you can get an idea that things are probably moving roughly from the northwest to the southeast. And this is all insects. It's all biological, except perhaps in the very northwest area of that blue, where there's these targets that kind of remain stationary in northeast Nebraska. And what's going on there is probably the radar beam bouncing off wind turbines. So we can also detect those. Those contaminate our data, but they're out there. So basically, there's a lot of non-meteorological stuff that we detect. And when we talk about Doppler radar, what Doppler radar does is it detects the motion of things, whether it's moving toward the radar or away from the radar. And that's going to be significant when we talk about distinguishing birds from insects. So what's going on here is the green is where things are moving toward the radar, and red is moving away from the radar. So there's a general north or northwest wind here as things are moving toward the radar from the northeast Nebraska, moving into southeast Nebraska. And these are all just insects that are kind of moving along with the wind. And that's what you're picking up here. So if you go back here and you look at the same arrows, you can kind of see perhaps a general sense of motion. You can see some of the areas where the blue is a little darker, and you might perhaps have a few birds there, or perhaps a greater concentration of insects. Another thing, if you look closely, right around the radar, just west of Omaha, you can see some areas that are darker blue, and they kind of trace out the outlines of rivers. And I believe that's just a greater concentration of insects there. So we can track things like insects with radar, and um, this is fairly common. You see a lot of radar images that look like this. Another type of non-meteorological echo that we track is smoke. And so what you're looking at here is an image from April 6th of 2023. And I have April 7th as well after this. And so what's going on here is you can see this this blob of blue that looks perhaps a little bit like the insects, except you see areas in there where there's darker blue. What you're actually picking up here is smoke from prescribed burns. This is about a 3 hour long loop, if I remember what I did for this. It's about 3 hours long. And what you're seeing here is smoke from prescribed burns in Kansas, and you can see the smoke kind of moving. And so in East Central Kansas, you kind of get a sense of emotion from east to west. And if you look in northern Kansas, you can see the smoke plumes kind of moving the opposite way. But we can use this to track things that are related to air quality. Now, it might appear initially, how do we distinguish what's smoke from insects, and how can we do that? Because it's all just one big blob of blue. Well, the good news is that with the dual pole radar that I talked about, we can look at something called correlation coefficient. And I'm not going to go into detail about what that is, but what you'll see here is some areas that are just very dark blue in this. And those areas that are dark blue that you're seeing are smoke. And the areas that are more green or orange or red, those are insects. They're not smoke. And so we can use this information from the radar to make the distinction between, say, insects and smoke plumes. And we can use this for tracking where the smoke is going, who's downwind of it, and how the smoke plumes are dispersing. I'm going to show you an example from the next day, which is April 7th. The winds were considerably stronger. And if you look at this, you get an idea that the winds are out of the southeast or out of the south. And there's a considerable amount of smoke here. And I believe on this day there were air quality alerts in Nebraska because of the smoke that was coming into the state from prescribed burns in the Flint Hills in Kansas. And again, the question comes up, how do we distinguish the smoke from insects that are also being blown along with the wind? And we can look at the same product here. And you'll see these plumes that are dark blue, and you kind of get a sense of the motion of that. And so the dark blue areas are smoke from these wildfires or prescribed burns in some most cases that are moving. And we can use this for wildfires as well. But you can get a sense of that that the smoke is being blown into eastern Nebraska. And we can use this for tracking air quality. Now, a caveat of this is you'll notice that when you get to about the Nebraska border, we really don't detect anything. The reason for that is as the radar beam gets farther away, it gets higher above the surface, and the smoke plumes really aren't rising that high. So we don't detect what the smoke is doing once it gets into Nebraska because the radar beam is simply above the smoke and we're not picking it up. But we can get an idea still of where these smoke plumes are going by looking at this product and distinguishing it from the insects, which in this case are in yellow and red. So we can use this for tracking smoke plumes and perhaps getting a more fine-grained idea of where there are air quality issues. Because I remember looking at the air quality monitoring from this day and trying to get an idea of just how bad the air quality was around much of Nebraska and Kansas. And what I saw was that a lot of the stations, particularly when you get away from big cities like Lincoln, were somewhat far apart. And so I think we can use this information to perhaps get a more fine-grained idea of where the pollution is going. So this is what we can do, at least in terms of smoke and air quality tracking. And we could do this in real time if we wanted to track where these smoke plumes are going, and perhaps incorporate data from other radars to get a picture of what's going on elsewhere around the state, or in Nebraska or areas over in Missouri where there were also some fires on these days as well. I also want to show an example of what we can do with birds. And radar can also track migrating birds. Now, the challenge once again is distinguishing the birds from the insects or from anything else that's going on. Now, if you look in the southwest portion of this image of this loop, you'll see what kind of looks like almost an explosion, a ring that's going outward. And so this is early in the morning near Green Bay, Wisconsin on August 2nd, 2017. And what you're actually seeing here is some birds that are leaving where they had stopped for the night and just flying off into the air. And you can actually see that happening. And you can see other areas where the birds are kind of streaming along or departing in the morning here. And so one of the things that we can do is we can kind of try to distinguish where are the birds versus the insects and use this for tracking birds with a very fine-grained resolution of where the birds are, where they're roosting, where they're going. And we can use this information perhaps to get a much better idea of bird migration routes and where they're going. And one example I gave is we might be able to use this for tracking where birds are most likely to fly, because perhaps we want to site wind farms out of the path of typical bird flight routes. So we might be able to use this information perhaps over longer periods of time to get an idea of where we would be able to best put wind farms so they don't kill as many birds. So how do we distinguish between birds and insects? Because you're also probably picking up a very large amount of insects in the middle of summer in this area. So one of the things that we can do is we can look back at the Doppler image, and remember that the green is kind of moving toward the radar, red is moving away. And you'll see some areas where you just have like bright red colors where the birds are moving much faster than the wind, or they're moving in a different direction. And we can use this information along with other things to kind of make the determination that that those are birds, because they're not really following along with the wind, whereas the insects do that a lot more. So we can use information like that to help us distinguish between birds and insects. And I want to show an example of how this is already done, and it's not nearly as precise in terms of spatially versus what I showed you here, but I'll show you an example of that. And this is a loop from April 1st and April 2nd of 2023. And it's on a site called birdcast.info. And what they're doing here is they're trying to track the concentration of birds in different parts of the US and get an idea as well of where they're going. And so I'm just going to play this loop for you, and you'll see as you go through the day. So this is beginning basically at noon Eastern, or at I think 6 p.m. Eastern. You'll see it go in and later on into the night, and you'll see these birds um, flying along, and you'll see where, particularly in the Central Plains, where it just really lights up. And then once the sunrise with that yellow line, you see changes in the amount of birds that are in flight. And I'll loop this through. I'll turn up the speed a little bit, but this is an example of what's already done for tracking birds. And so this is kind of I thought it was a really cool image, and you can get the archive data going back several years on birdcast.info. And so again, like I said, this is already done, but the caveat here is that it doesn't really provide you with smaller scaled information. It's really focused on how many birds are flying around each of the radars around the US. And you can see each of the radars with the green and red dots on here. And so it's basically trying to get an idea in all of the area that this radar is scanning, how many birds are in flight and where are they generally going. And I think what I can do with these algorithms is get much more detailed information spatially about where the birds are flying at a particular time or on a particular day, and perhaps build a large data set of where their most typical routes are, where they tend to roost and things like that, and to get something that's perhaps more detailed than what you see here. So I want to go back to my slides and show a little bit about how this is done. So there's actually an algorithm that is used to distinguish birds and insects. In fact, I've seen a couple of different algorithms for this. And here's an example of this. And you would have a radar image that perhaps looks not unlike the blue blobs that I've been showing earlier in this. And what you see here is an attempt to classify what those are. And so the things that are in green are perhaps light rain or something like that. The things that are in the areas that are in yellow are insects, and you see a lot of insects around these different radars. And then the areas that are in red are identified as birds. And you'll see in many cases, I believe this is 4 successive images. And if you look down in the southeast, here inside all these different black rings, you'll see where you kind of get rings as the birds are taking off in flight um, during the morning. And so we can use this to get an idea of where the birds are taking off and distinguish them from insects, and perhaps get a better idea, a more detailed map than what I was just showing you. And we can track this in real time. We can build a large climatology going back a little more than 10 years using the data that we have. So this is my last slide, and I want to kind of reiterate what I think we can do with this. So one of the things that we can do is tracking smoke from fires. And again, one of the advantages is that we can also see at night versus just during the day. We can do real-time tracking of migratory birds with a high degree of spatial detail. And we could perhaps build long-term, more detailed maps than what you typically see of flyways with migratory bird flight. And I offer the example of wind farms, but I'm sure there are better applications or other applications of this as well. Um, I don't know what these are. I'm a meteorologist, but I wanted to just kind of describe the capabilities of this. And also, to be honest, a few of the caveats of this. So we have a limited amount of data here. We have a little more than 10 years from when we started collecting this data. One of the big issues that we have is we're limited to areas that are relatively close to the radar. When the radar beam gets farther away, it gets too high above the ground to really track birds or smoke plumes that are near the surface. So we're kind of limited in the range. And if we don't have a lot of radars, if you go up to like the sandhills in north central Nebraska, you don't have real good radar coverage. So we're probably not going to get as a lot of information in those areas. But perhaps close to Omaha and Lincoln, or close to Hastings, or out around North Platte, we can get some pretty good information about this. It really depends on how good the radar coverage is. And another issue that we see, I've shown the examples from smoke in Kansas, and I took a look on some of those days in Nebraska, and the radars here weren't actually detecting the smoke plumes, probably because they became too diffuse once they got into this area, because you kind of see them spreading out as the smoke moved north into Nebraska. And so it's going to be difficult once you get really far away from the fires to track the pollutants. So those are some of the caveats here. So I wanted to provide just kind of a general overview of what we can do, and what options we have, what works, and what the caveats are, with the idea, with the hope that there are potential collaborations where we can implement some of these algorithms and develop this further. So that's what I have. If you have any questions or comments for me, I'll be happy to hear them and answer as best I can. And also, my email address again is down at the bottom. So if you want a copy of these slides or want to discuss these with me further, feel free to reach out to me at that email address. So thank you.
Say,
Hey, George, this is Zach Rigg. If you can hear me, I have one question here. So are you able to pick up this biological data, even if there's like a storm event going on? What does it?
So if there's a storm in that particular area, the rain and hail and are so reflective that within that storm, you're probably not going to pick up any biological echoes within the storm, because it's going to be overwhelmed by the rain and the hail. On the other hand, if you have a radar image where you have some rain or hail, and then somewhere else in the radar image you have insects or birds, then yes, you can certainly distinguish the meteorological echoes, the storms, from the birds and the insects, but probably not within the actual storms. So hopefully
Okay,
that
thank
answered
you.
your question.
It did. Thank you.
Thanks.
and George, the website that you went to had the locations of some radar. Is that all of the radar stations that would be capable for this?
Yes, so that's the radar network in the U.S. and there are a little over 100 radars, and you'll see some big gaps in some of the radar coverage in parts of the plains. A big gap in South Dakota and northern Nebraska, and unfortunately, those are areas where the coverage isn't going to be very good. I'll put that link back in the chat again as birdcast.info. And the specific page I was looking at, if you go to it, you'll get today's map, but you'll see where the radars are in areas where you're pretty far away from one of those dots. You're not going to get real good coverage.
Okay, excellent, thank you. You might want to
Thanks.
put your email in the chat too, so that's easier to get to for folks. But any other questions for George? If not, thank you very much, George. It was great.
Thank you.